Hey guys, welcome back to another episode with Tracking the Coronavirus. Today we'll just be looking at data as of day 94, and that is April 2nd. Nothing new really, just looking at trends and just graphs and just trying to figure something out of it. So basically, we are headed in an exponential kind of direction. You can kind of see this blue graph. These are the actual cases here. And so this is the death toll, and these are the cases. Yeah, these are the cases, and you can see how we're headed to 1.25 million um, cases. Um, and if we look at just the infection rate, we'll see this kind of. I made this parabolic curve right here, but I think it's wrong to put a parabolic curve. I think it should be more of an exponential decay curve. And if you want to know what an exponential decay curve is, it kind of looks something like this. Um, we'll go to actually let's just go to a new sheet entirely. Um, Kind of looks like this. Some initial value times some fraction less than 1, positive fraction less than 1, to the power of x. Can we do that? Yeah, there it is. Yeah, this is what it should be looking like. This is our infection rate. Actually, this is what it should be looking like. You can see here I put a rate of 66%. That means 33% being dropped off for every x. But this is kind of what it should be looking like. So let's try to figure something out of that. Let's try to actually, if it allows me to edit it. Yeah, let's try to actually come up with something like that for this graph. So if I go to series, trend line, let's go to exponential, and let's actually try to make it decay. Notice here, it gives me infinite value to the power of negative 0.026x. That really just doesn't make sense. And the reason being, our units are actually in calendar dates. And so you can't really have that as an x. So we're going to go to setup here. And we're just going to put this at b. And b gives us an opportunity to look at it like if it was the day number. So obviously this is not the date anymore. We can kind of customize that later, but basically this gives us a better, you can see that yellow line, that is an exponential decay graph, and that's kind of what I want to be looking at. So this is kind of telling us 63.3 e to the power of negative 0.026x. Obviously we can graph that on Desmos, and obviously it won't be like this graph, it will be much more shallower, as you can see here, but you can see kind of how we started off with kind of like a 30% infection rate and how that's kind of decreasing as time goes on because the number of cases we should be having um, is not the same as the original. For example, if we go up 100 cases on the first day versus 100 cases on the 30th day, it should look very, very different. It should be a smaller percentage. Um, so yeah, we're just gonna go through that exponential decay. And let's look at deaths. So you can see how I've added that same line. Let's make that clear for you. Yeah, hopefully that makes it clear. But yeah, this is the graph. And here we saw around like 30%, and now we're headed to 0%, which is really good news. Um, and hopefully we go to a negative number, which means that our cases have officially gone down to 0. As with this graph, it should look like a hump. And that would be the number of active cases, I would say. A hump would be the number of active cases, but total number of cases that have occurred throughout this lifetime, you could say, would look more logistic, and I'll go through that in another video. So stay tuned, please stay in touch, and stay safe. Please take care, and I'll see you guys on the next video. Bye.